All right, so this is not a different section, but since we just learned all these rules, the big idea behind the second part is how in the world do we apply these rules, okay? And so we're gonna take a look at some different ways that you can get asked to use the rules, okay? I think it's really important to sort of right from the get-go think about how are they secretly asking me to use product rule? Or how are they secretly asking me to use quotient rule? Or how are they asking me to use, to find a derivative? Okay, that is, I think, one of the hardest parts about our course is that there's basically a bazillion different ways to ask you to find a derivative. Okay, so I really want to start us off knowing that there are so many different ways to do this and starting to see what those ways are, okay? So let's take a look at example 1. Okay, so example 1 has 2 pairs of equations in part A and 2 in part B. And what I'd like you to do right now is for part A, I want you to think about which one you think you need the quotient rule for and which one you do not. Okay. So if you think that this one in the yellow needs to use the quotient rule, then you're going to type yellow. And if you think that this one highlighted in the pink needs to use the quotient rule, then you're going to type in pink. Okay, so in about 20 seconds, I'll give you some time to think and type your answer into the chat. But in about 20 seconds, you're going to go ahead and type in either pink or yellow. All right. I hope 2 sneezes was enough time for you to think about pink or yellow. You're going to go ahead and type into the chat pink or yellow and hit enter. Pink. Yes. Okay. So pink, and I agree with you. I also love that somebody gave an explanation, which is that the denominator is more complex. Okay. Now, if I did this and I just crossed out the other terms in the denominator for the pink one, could we get away without using the quotient rule? That's sort of a weird question, but for the pink one, if I cross out the other 2 terms, do I still have to use quotient rule? Yeah, now if I cross those 2 out, I could use the same strategy as I used for the yellow one. Okay. And so let me sort of get rid of that. We could say that this one breaks down into 3x squared over 5 plus 2x over 5. And I think we could even say it like this: 3/5 x squared plus 2/5 x. And I think when we write it as that bottom line, it becomes really clear that we don't need to use quotient rule. Okay. All right, let's ask ourselves the same questions about B. And we'll go with pink and yellow again. So if you think that the first one needs product rule, you're going to say yellow. But if you think the second one needs the product rule, you're going to say pink. Okay, so let's take another 20 seconds to kind of think about it. Type your answer into the chat, and we'll chat blast in about 20 seconds. Okay. So pink or yellow, which one do you think requires us to use the product rule? Ready, set, go. Okay. Yeah, so if we were to simplify this yellow one, we would know that we have to maybe write it like this could be a good first step, and then we could simplify it more. And then we could just use power rule for each term, okay? Now, I would say that pink is like a, yeah, we could use product rule here. What or what specifically makes the pink one the one we think we have to use product rule for? Yeah, different things being multiplied. Okay, so if I try to simplify this one, I get 3x sine x minus sine x plus 6x minus 2. Do we know how to take the derivative of this? Like, could you find the derivative of just minus 2? Okay. Can we find the derivative of 6x? Yes, okay. Can we find the derivative for sine x? Okay, so some people are saying yes, we have not technically learned it, but if you Google the derivative of sine x, that is something that you could find. And so we're actually going to learn about that in a couple weeks, okay? But let's take a look at this term. Even though I FOILed out, I still have 3x times sine x. Okay, do we see that? 3x times sine x. That means that this still requires product rule. So even though we simplified, we multiplied everything out, we were not able to sort of combine everything to the point where we didn't have any more multiplication. And since we didn't get to a place where we don't have multiplication, we still need the product rule. Okay. Any questions about example 1? Okay. Let's take a look at question number 2 over here. Okay. So question number 2, I'll give you a moment to read it for yourself. And then what we're gonna focus on to start is just part A and part B, okay? So read through the question, and what I'm hoping that we can get a few ideas on is what is question A and B asking, and being able to convey that in words, okay? So take a moment to do some thinking, but what can we say that part A and part B is asking in words, okay? All right. Any brave souls feel like they can say part A and B in words? All right, we've got one response in here. Let's see. So the product of F and G and the derivative of it. Okay, I would agree that we could say that part A is asking, find the derivative of F times G. Okay. So find the derivative. Now, what part of that says find the derivative? Because I think that's important to highlight for ourselves. How do we know that it's saying find the derivative? That prime, right? So this prime is really the find the derivative part. Okay. But mathematicians are lazy. We don't want to sit and write out all those words. So we're like, put a prime here. They'll know it means find the derivative. Okay. Now, how do we know that it is saying F times G? Like, what part about the question says F times G? Yeah, the part that literally says FG, right? That might be like too easy of a question to ask, but that FG means F times G. Okay. And so that's kind of how we unpack the notation there. How could we translate part B then? Because it's a little bit different. Yeah, FG turns into G times F. Okay, so find the derivative of G times F. Okay. All right, well, let's take a look at C and D. How do we modify the language we've used in A and B to write in words what C and D are asking us to find? The derivative of F divided by G or G divided by F. Okay, so find the derivative of F divided by G. And this one says find the derivative of G divided by F. Okay. So now I'm taking time to write this out right now because, you know, you could be doing this quiz later or doing some web assign later or whatever it is, and you see just the notation and they don't even show you any words, like there's no directions. It just says FG prime of F of 5. And it's kind of like, well, what does that even mean, right? So I want to show you that structure so that when you're doing these problems, you can understand what each part is telling you, but also, like, if we're trying to explain our thinking to each other, I think this gives us some language to use about what it's asking. Okay. All right, so let's go back to A then for a moment. If I say find the derivative of F times G, what rule am I like, please use this rule? Yeah, product rule, right? We see times and we're thinking product rule. Okay, well, we must be using product rule for B then as well, right? And for C and D, we see derivative of F divided by G. Oh, shoot, they're asking us to use that quotient rule. Okay. So you'll notice that this question has no equations. Like I didn't say f equals x squared minus 2x plus 5 and g equals the square root of x. Like I didn't give you any equations at all. And so what these kinds of problems are all about is getting to that concept and knowing the rule, okay? So it's really connecting the concept with the rule so that you can get an answer without worrying like, did I distribute that negative sign right? All that kind of stuff, okay? All right, so the product rule gives us u dv plus v du. If I use the letters I'm given, that's like f g prime plus g f prime. You write out the rule, and then we think about what value of x we're looking at. So specifically here, we have f of 5 times g prime of 5 plus g of 5 times f prime of 5. Everybody see where I got that 5 from? Yeah, okay. So all I've done is write out the rule. Your last step here, plug in the numbers they give you. What are we going to put for f of 5? 1, beautiful. What are we going to put in for g prime of 5? 2, love it. Plus g of 5. Let's see, look all the way back at the top. Yeah, -3. And f prime of 5 is 6. Okay. That's an ugly 6. Let's fix that. Okay. Well, I think we can all do this. 1 times 2 gives us 2. -3 times 6 gives us -18. So we should get -16. And so what does that mean? That means I've got these two functions. I multiplied them together, and then I wanted to find the slope at x equals 5. That slope is -16. Okay. Let's try D. Let's try D. We said for D, it says find the derivative of G divided by F. And that G divided by F said quotient rule. We want to know that quotient rule. So I'm going to write out the quotient rule here. Okay. Low D high minus high D low over low low. Which function is our low? Okay, so let me be clear on my question here. I don't want us to substitute in numbers yet. I just want us to identify like which function is the low function. Okay, so f is the low function. F is the low function. Okay, that means that g is the high function, okay? Okay, so the reason why I'm asking you is because if you go back to the formula that we just learned, we had an F on the top and we had a G on the bottom, right? It's one of those things that is really confusing about math sometimes. We kind of use these letters, but it's less about the letter and more about where the letter is. Does that make sense to folks? It is less about the letter and more about where the letter is. So F is on the bottom, that is my low function. G is on the top, that is the high function. Okay. What's my low function for C? Okay, so it switches, right? G is what we're going to put for the low function. F is what we're going to put for the high function in C. Okay, so I wanted to do D because I wanted us to just be aware. We got to be really thoughtful about where things are and less what they're called. Okay. But I know that folks were already grabbing some numbers here. So let's just make sure if I write it out in symbols, we know what numbers go where. So for low, I'm going to have F of 5. And for D high, I'm going to have G prime of 5 minus G of 5 times F prime of 5 all over F of 5 squared. Okay. Now that we have this, and this is something I expect to see in your work, by the way. Okay, so writing that out, now you can substitute in your numbers. We're going to see a 1 times 2 minus negative 3 times 6 all over 1 squared. And I believe that gives you an answer of 20. Okay. And so what does that 20 mean? Can someone explain to me what the 20 means? Okay, so G, that 20 is the slope. But the slope of what? Let's be a little bit more specific. Okay, maybe I'll write this out so we have some sort of framework to go back to. So this is the slope of it's the slope of something at x equals 5, right? Secant line. So let's be careful about our vocab here. Secant line. Yeah, it's not the secant line because that goes through 2 parts of the curve. Tangent. Yes, it is the tangent slope of the tangent line of what function? So it's the slope of the tangent line of what function? G over F. Okay, good. So it's the slope of the tangent line of G over F at x equals 5. Okay. All right. I'd like to spend some time in breakout rooms. And before we do that, let's take a look at question 3. Okay, at question 3. I'm wondering if you can tell me what rule you think we need to use in order to find that. Okay, I'm going to write that here. We're going to need to use quotient rule. All right. Now, one thing I just want to put in your brains is that write out the rule. Do not plug numbers in until you get to the end. Okay, let me say that one more time. You're going to write out the rule. You are going to be patient and not plug numbers in until the end. Okay. All right. Different kind of way of asking that question. We've got some pictures of these graphs now. U of x. If I'm asking you to find u prime of 1, what rule am I asking you to use? Okay. Product. All right. V of x looks like that. What rule am I asking you to use here? Beautiful. Okay. Last hint before we move away from this question. How do I find this on the graph? Or rather, what is this from the graph? If I don't have an equation, how am I supposed to find that? Thea, how'd you get 4? So spot on. F of 2 is not asking for the slope. Okay, so this is the y value. I love these. I don't love the graph, so let me highlight one thing for you real quick. Let's maybe use this color. This is where the x-axis is. This is where the y-axis is. Okay, I wish there was a way I could make that more bold for you, but that's where the x and y-axis are. Okay, how would I find this? Because I don't have an equation. How would I find f prime of 3? Right? I can't use power rule. I can't use quotient rule. I can't use product rule. I don't even have an equation. How am I supposed to find f prime of 3? I don't want to know what it is. I want to know how we find it. Find the slope. Slope of f at x equals 3. Well, how do we find slope? I mean, we don't even have an equation. How are we supposed to find slope?
Well, it's just, it's just a graph that has linear sections. So if we just go to f of 3, we're able to actually figure out 2 points that lie on the points tangent to f of 3. So rise over run basically is just finding the slope of a linear function.
Okay. Okay. That's tricky, right? It seems like you don't have enough information. But if we think back to our definition, derivative means slope. And slope is rise over run. And if it's a straight line, I can just count it. I can just look at the picture and count my slope. Okay. All right. I think this is a good point to sort of pause. And what I'm going to do is I'm going to put you in some breakout rooms. I'd like you to take a look at 3 and 4. Okay. If you are able to finish those, you are welcome to look ahead and kind of think about that a little bit more. But let's take maybe about 15 minutes and kind of see where we get to. Okay. We'll come back together. We'll take a look at our thoughts. And I'm more interested in the thought process, though if we have a solid thought process, it should lead us to an accurate answer. Okay. So I'm going to pause the recording now. All right. So how did that feel? Uh-oh. Okay. That's super fair. All right, let's take a look at example 3. Okay, so for example 3, yeah, exactly, right? These kinds of questions, like, even though we're secretly asking you to use these rules, we're sort of taking away some of that computation layer. And so sometimes it like really makes us focus on the actual concept rather than like how to do it, okay? So if it's feeling a little tricky right now, that's okay. Let's sort of unpack number 3 and see where that brings us. And so before I sent you to the breakout room, someone said, oh, for 3, we need quotient rule. And I thought that was such a good observation because we zoom in a little bit here, and forgive me, I can't remember what colors we're using yet anymore, but we had a function on the top and another function on the bottom. And so since we are trying to find a derivative, I think that's how someone was like, oh, we're dividing things. I want to find the derivative, so let's use the quotient rule. Okay. So I know some people are like, they're like, do I have to write out the rule every time? I mean, you don't have to, but I find it helpful to have something on paper rather than nothing on paper, right? So if I were to just write out the general quotient rule, I might write that we have low d high minus high d low over low low. Okay. And I find it a little easier to use the low and the high when I have other letters already given to me, but you can certainly use U and V or F and G, whatever letters make you feel better. Okay. So here's our quotient rule. Well, our process is not necessarily different. We're going to set things up. Then we're going to substitute into the rule. And then we're going to simplify. So we'll do substitute here. And then simplify. Okay. All right. So set up for quotient rule. I need to know which function is high and which function is low. All right. So you tell me, what's the high function? What's the low function? High is h of x. I love that. That's the pink one and it's on the top. And x is the low function because that's the one on the bottom. Okay. Now I know that this might seem really straightforward for some of us, but are we all okay with identifying high and low?
I have a question about that actually. So how do we know when it's reversed or when it's flipped? When, like, for instance, when it's like F divided by G, where it would be the complete opposite. The high would be the low and the low would be the high.
It's not opposite. The low is F.
Like, for example, 2C, where you said like it would be the opposite.
What is high and what is low?
F, and then the low would be G.
Perfect. That's it.
Oh, okay, I see. Okay, it doesn't really matter, just like as long as we're paying attention to what it's on top of or on the bottom.
Yes, yes,
Okay,
yes. And the only reason why I made a big deal of that is because the rule, it's not in this document, but the rule we learned had the G on the bottom. And sometimes people just think G is always on the bottom, but it's really about like what's on the top, what's on the bottom.
Okay, that makes perfect sense. Thank you.
Okay, all right. So are there any other questions about how we identify the top function and the bottom function? Because I think that's a really important piece here. Okay. Yes. Yes. Okay. So I know this is weird because in the past, when I've said find the derivative, like you had a function, right? So how do I represent the derivative of the high function? I don't have to know what it is. I just want to know how to write it. H prime. Good, 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 good. So H prime of X. Okay. Now this is the part where it's like, this is weird. I don't know what it is, but I know that H prime means derivative. Okay. Now let's go over to our low function. We know that low is X. So d low gives us what? Can we find this derivative, or do we need to leave it as like a prime notation? Okay, but what is it? We've learned so many rules now. Yeah, this is a case where we can use the power rule. This is x to the 1. So we can use our power rule, 1x to the 1 minus 1, which gives us 1. Yeah, okay, okay. So I think this is maybe where some of that confusion was, right? Is that we're mixing and matching. Sometimes we can find the derivative like x. If you can find that derivative, find it. But sometimes they just say, here's this function, leave it as the derivative of this function. And that's okay too. Okay. So how we feeling about the setup right now? Maybe give like a quick thumbs up or, okay. Better, better, that's good. Even if you're not entirely there yet, a shift in the direction towards getting to be, I've totally got this, is a good place to be, okay? Okay. Now, after we set up, we substitute. We're gonna substitute it in to our quotient rule. Okay. Whoops. So I'm gonna get low, which is x, d high h prime of x. I know I don't know what that is yet, but I'm just going to write it anyway. Minus high, which is h of x, times d low, which is 1, all over low, or x squared. Now let me pause for a moment. How we feeling about the connection between these two, between our setup and substituting everything in? Does that make sense? Would we like some color coding to make sure we know where things went? Is that overkill? All right, so we've got our setup. Now what's important here is that we need to be really thoughtful about our setup, because once we substitute, we want to make sure we're plugging in the right terms, okay? Now the last piece that we need to consider to finish this problem is, what value of x am I going to use? Okay, and in this case, they want you to find the slope at x equals 2. And so everywhere we see the x, we're going to replace that with a 2. Okay. Let me maybe bump this down here a little bit. Okay. So if I substitute in a 2, let's see what we get. 2 times h prime of 2 minus h of 2 times 1 all over 2 squared. Okay, so again, we've got our formula. We were patient, and at the very end, then we substituted our numbers. Okay, so now that we see some numbers, maybe we're feeling a little bit more comfortable with this. Like, we know 2, we know 1, we know 2 squared is 4. That's all great. But some of us might secretly still be panicking about h of 2 and h prime of 2. Like, if I don't have an equation, how am I supposed to find h of 2? If I don't have a picture, how am I supposed to find it? But before we sort of go down that negative spiral of we don't have enough information, or sometimes that turns into I'm not good enough to do this, right? It's a very fine line. We want to think about the stuff that we skipped over at the beginning. Everywhere I see an h of 2, I'm just going to put a 4. So we're going to have a 4 go right there. What am I going to put instead of h prime of 2? Yes, right? Go back to that problem. Turns out all that stuff we skipped at the beginning came in really helpful to help us conclude the problem. Because here's what we actually have. 2 times -3 minus 4 times 1 over 4. -6 minus 4 over 4, -10 over 4, or -5 halves. Okay. How are we feeling about this question now? Now that we've seen the setup, the substitution, the simplifying. Give me a 1 in the chat if it's better, a 0 if it's the same, a -1 if it's worse. All right, 1, 0, or -1.
Professor, I had a question.
Absolutely. What's up?
So, is it implied that we substitute at the very end, like in these kind of problems? Because if we substituted just a bit earlier, like we'd get different answers, right? Like when I saw x equals 2, I didn't see x as a function. I just saw it as like 2 then, initially at the front line. So like, is just to accept the principle to always sub in at the last step?
Yes.
Okay.
And
Gotcha.
reason why is because as soon as you substitute in a number, what's a derivative of just a number?
0. That's why, yeah.
Yeah,
That makes
exactly.
sense. Okay.
You basically end up with 0 every time you do that if you sub in too early.
So I guess then, like, why did we try to find the derivative of x? And then, but then for like h of x, we still left as h of x. Like, why did we go one step further with x, and then with h of x, we still left it as a...
We didn't, it's not h of x on that second one. It's h prime of x.
Well, that's what I mean. I mean, they already give us the values, so it wouldn't have hurt to just use the numbers there, right? Because those values are known, right? Like
Yes.
if we put
yes, and I've had students do that in the past, and then maybe that particular student understands that these require a different strategy than these ones.
okay.
But then when they share that with someone else thinks you can sub in all the values at the beginning, and then that someone else gets the wrong answer.
Okay.
Gotcha. Yeah. Okay.
All right. Understood.
Yeah.
Thank you.
But if for you that makes sense, you can certainly sub in earlier if it's a known value, but then you really have to think about like, why is x equal 2 not considered a known value for low? Okay. All right, so I see a bunch of 1s, a 0.5, some people who didn't respond. I don't know if that means you're like off the charts negative here, but if you are, I hope you come to office hours this week or go to tutoring sessions, okay? All right. All right, so for example 4, how did this one go? Better, worse? What do you think? Worse. Oh gosh. All right.
I think for this one at first we found where like f of 1 and g of 1 is, and then same with the f of 5 and g of 5, and then we also looked at the slope for it.
All right. Let's find our setup then. Okay. I think we could set this one up. So we get f of 1. Okay. Now f of 1, and then I got to find f prime of 1. And then g of 1 and g prime of 1. All right. Now I know this because product rule says fg prime plus gf prime. So I know I have to have all these values, okay? So let's take a look at the f picture from the pink graph or purple graph, whatever color you think it is. What is f of 1? So on the pink graph at x equals 1, what is the y value? 2. Great. Okay. What is the slope of the line right there? Like if you were to count rise over run around that point, what would you get? You'd also get 2. Yeah, exactly. Okay. Blue graph. What is the y value of the blue graph at x equals 1?
1.
Okay. What is the slope of the blue graph at x equals 1? Good.
-1.
Perfect. Okay. So now Moon, back to your sort of question about when to sub in values. In this case, everything is sort of the same, meaning like I have a picture to go off of. There's no like this one's an equation, but that one they already give us. So because of that, we can go straight to the numbers. Okay.
Okay, good to know.
When we're looking at our derivative, now we're going to plug in things into the product rule. So u prime of 1 equals f of 1 g prime of 1 plus g of 1 times f prime of 1. Plug in your numbers. 2 times -1 plus 1 times 2. And then simplify. U prime of 1 equals -2 plus 2, which gives you 0. Okay. So the key to this question is the concept. What is a derivative? A derivative is slope at a point. Okay, a derivative is slope at a point. I know if I just gave you a graph, you could count rise over run. But now we have to understand that that's part of the process to find this answer. Okay. All right. B is very similar, except we're using a different rule. The setup should be the same. The simplification be the same. It's just that middle step, you plug it into a different rule. Okay. So I'm going to finish B on the notes before I post them. So you'll have that. But before you go, what I want to do is just update some information about the quiz. Okay. So for the quiz, please complete the following questions: 1 through 5, 9 through 11. Okay. So for quiz 4, please complete 1 through 5 and 9 through 11 only. We will get to the other questions when we come back on Monday and finish these up. Okay. But 1 through 5, 9 through 11, pass the message on to anyone who might not have been able to make class today, okay? Not that that's on you as a person to take care of other people, but I think out of kindness, maybe just send a reminder. That would be awesome. I will also update it on Canvas. All right. All right, folks, if no one has any questions, that's a really good point. Let me double check WebAssign and I will email you by the end of the day about WebAssign. Is that okay, Gloria?
Yeah, if nobody else has a question, I'd like to ask about the string art.
Oh, yeah, okay.
So I was doing it and you know how usually everything saves on your account, like if you create a Desmos account?
Yeah.
I tried accessing it again and it doesn't like let me or doesn't give you an option. But I'm still like doing it. So I'm on the slide. After finishing it, it should submit like usual, right? Like
on to my Desmos real quick and just make sure.
okay.
I,
Yeah, because I'm like doing so many like you know the graphing part and I'm like, no, I don't want to like have to redo this again.
yeah, okay, let's make sure. Oh, okay. I think what I need to do is assign it. And
Okay.
then it should save everything.
Oh, okay.
Okay, let me assign this to Math150 Spring21. Okay, so now it is under the Desmos class that we have. So that means that I should be able to see what you do and you should also be able to go back and see what you do.
Okay, thank you.
Okay, fingers crossed. Please let me know if that does not help and we can take a deeper look at it.
All right, thank you so much.
Okay. All right. Cool, folks. If you don't have any other questions, have a great rest of your day. See you later.
Bye, Professor. Thank you.
Bye. Bye, Omar. Bye, Aylin.
Hi, Professor.
Right.
Yeah, so I didn't want to